All right, so number 5 on the back. Calculate G at a point 6.37 times 10 to the 6 meters above the surface of the Earth. So that value is not that much different from the radius of the Earth. Okay? And the radius of the Earth is not given in the problem, so that's something that we have to look up in the book. And in this chapter, I think they had a little table that had like constants like the mass of the Earth, the mass of the Moon, and if not, it was in the back of the book. So first, let's look at our picture. Here's the Earth. So in order to do this problem, we would have to look up the radius of the Earth. Okay? So the radius of the Earth is 6.38 times 10 to the 6 meters. Then they want to know what is little g, a certain distance above the Earth. And the distance above the Earth is, they said, is 6.37 times 10 to the 6 meters. And they want to find little g. So we know that weight is equal to mg. And we know that universal gravitation is big G, m1, m2, in this case, my object and the mass of the Earth over the distance between them. If we set these two equal to each other, we see that little g is equal to big G, the mass of the Earth over the distance between them. So this is one of the equations that was in your notes. So you can either memorize the equation in this form to calculate little g, or what you could do is you could just set one equation equal to another. So everyone, remembers things differently. Some people think it's easier just to memorize another equation. So the trick to this problem is that this distance is from the center of the Earth to where this object is. So this r is actually going to be the radius of the Earth plus the distance. So now when I want to calculate little g is equal to big G, 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared, times the mass of the Earth, which is 5.98 times 10 to the 24 kilograms, divided by this distance between them, which is from here to here. So that distance is going to be the radius of the Earth, 6.38 times 10 to the 6, plus the distance above the surface of the Earth, 6.37 times 10 to the 6. So now when we do it all together, and this is squared on our calculator, you might want to just add these two first to make it simpler. So let me do it here so we can look at what buttons we're pressing. 6.38 EE6 plus 6.37 EE6 equals, so it comes out to be 1.23 times 10 to the 7, and that's going to be squared. So now when I put the whole thing in the calculator, 1.28, whoops, because it's 1.275. So now when I put it in the calculator, 6.67 EE to the negative 11, remember I don't press times 10, times 5.98 EE24 equals, divided by 1.28 EE7 squared equals, and then I get 2.43 meters per second squared. So that's little g. So when we're reading these problems, something like this, obviously it's easy to make a mistake because little g at the surface of the Earth is going to be 9.8 meters per second squared, but it didn't ask at the surface of the Earth. It asked for a distance above the surface of the Earth, and this distance above the surface of the Earth is almost equal to the radius of the Earth. So it's much, much further than the International Space Station flies or anything like that. It's actually quite far. And that's it.